Unit 4 Chemistry, Chapter 11, Part 3, Reactions of Functional Groups. So it's not just alkanes and alkenes that can react. If we add a functional group, they can also be involved in reactions. So chloroalkanes, or indeed any haloalkane, for instance, can react, and they will react much more readily than the alkane because the electronegative halogen is much more reactive. Okay? It essentially weakens that bond, so it can be replaced with another functional group. Because we're replacing it, we're substituting it, so it's a substitution reaction. And we can substitute a chloro, for instance, for an alkanol, or we can substitute it for an amine group. Okay? It just depends what we reacted in. So to get an amine, we'd react it with ammonia. To get an alkanol, we'd react with some hydroxide ions. Okay? In doing that, what we are doing is taking off this chloro group and replacing it with a whole new functional group, which I'm sure you realise there should just be NH2, although in solution, as we say, this is a base, so it would become NH3 positive. Okay, and that smudge there, that's a positive sign that you probably can't see too well. Okay. Similarly, we could remove a bromo group and replace it with hydroxide ions, and by doing that we are making a alkanol. Okay. You're seeing some of these diagrams, by the way, which look a bit unusual. You need to get used to seeing ones like this. You're not going to be asked to draw them. These bonds are still just single carbon bonds, carbon-to-carbon bonds. What they're trying to do here is demonstrate shape. So they're trying to show a 3D shape on a 2D piece of paper or screen. So that's why they might look a bit weird. Okay. Once we've made an alkanol, we can also undergo a couple of other reactions. So if we've got a primary alkanol, remember that means the carbon's on the end, we can oxidize that to make a carboxylic acid. Okay. If we've got it in the middle, then we can also oxidize it, but we can't make a carboxy group. We're going to make a ketone instead, a carbon double bond oxygen. Okay. Tertiary alkanols, can't oxidize them. If we're going to oxidize them, then we need an oxidant or oxidizing agent, something that's quite strong, which would normally be permanganate or dichromate. Okay. So our primary alkanol can be converted into a carboxylic acid. It says here with the presence of oxygen. Okay. Normally that oxygen is coming from something like, here we've got potassium dichromate, and we need an acidic environment. And if you started writing out your half equations and balancing them using your Cohees method, which you will need to do, that will give you an indication of why we need the hydrogen ions, because you'll see them in your half equations. You'll see them in both. The potassium here is a spectator, and where it says under reflux, that means undergoing a redox reactions. You might see that sometimes they say reflux with, that means does a redox reaction with. Okay. If we have our secondary alkanols, and again, where we say oxygen, we're really using an oxidizing agent, we are going to be able to get a ketone instead. Okay. Primary alkanols will normally make a carboxylic acid. They could at times also make an aldehyde. Okay, so here we're just adding the oxygen there and double bonding to it. Okay, we're not adding two oxygens to it. But both are certainly possibilities that can arise. The final reaction of functional groups is when we have a ester being made from an alkanol and a carboxylic acid, and we call this a condensation reaction. It's a condensation reaction because it makes water, and the ester is made between the two functional groups. We need a catalyst, and that catalyst is sulfuric acid, and it's liquid sulfuric acid, nasty stuff, about 98% pure. Okay. We're going to make our ester functional group, which is the carbon double bonded to one oxygen and then bonded to another oxygen with a carbon chain on both sides, which remember is what these R's are. Okay. So we would have our carboxylic acid and our alkanol reacting together to make our new ester group and water. So if, for instance, we had propanoic acid and ethanol, we're going to make ethyl, here's my ethyl, propanoate, which is there. We can, of course, reverse that reaction. Okay? Esterification is making an ester by a condensation reaction. If we add water back to it, which is called hydrolysis, hydro for water, lysis meaning break apart, okay? Then we are going to take something like our butyl ethanoate that we've got here and split it up back into the ethanoic acid and the butanol. Okay? Acetate or acetic, that's an old-fashioned name for ethanoate or ethanoic acid.